This is the final example of 2.6 day 2, but it encompasses basically everything that we've been doing so far in the section, puts it all into one, something called a complete analysis. Now, when I refer to complete analysis, or when you see it in the book and it asks you to do a complete analysis, the list that I'm going to expect from you is right here. So I want you to take a minute, maybe pause the video, write down this list. It looks like a really long list of things that we have to figure out for this function, but it's actually smaller than the list that the book has. It actually is quite pared down from the author's interpretations of what a complete analysis should look like. So even though it looks like a ton, I think this will save you some work if you write this down and follow through with our example here. One thing you'll notice, big bold letters, says to factor first. So we've got this rational function. We should factor it. It will help us on certain parts, but we're going to factor the top as x minus 2 times x plus 1. Bottom factors as x minus 4 and x plus 2. If you are having trouble with how that factors and you want to pause the video, maybe it's a good idea to pause it and see if you've got the factoring down before you go through with the rest of this video. Now we need to figure out just a bunch of different things about it. We have intercepts, asymptotes, domain, range, and then also there is limits. That'll be on the next page. It's a lot of stuff here, but we'll just do one at a time. You pick off whatever you think is easiest to you, or whatever sticks out first. X-intercepts would be one of those things. So if I've got x-intercepts, it's just whatever makes the top equal to 0. And so we have that factor. That's why we factored it up here. It's just going to be 2 and negative 1. So that's kind of nice that those are just, all you need to do for those is just the numbers. You don't need to have the equation form. For y-intercepts, we're going to, again, just plug 0 into everything you see here. So anywhere you see an x. Plug in all those zeros, what you do, then they all cancel out, and what you'll get is negative 2 over negative 8, which simplifies to 1/4, and that's going to be our y-intercept. We'll graph this in a little bit, but you can always check things on your graph and verify just to make sure everything's going the right way before you call it good. Vertical asymptotes, those are going to be whatever makes the denominator 0, as long as it doesn't represent a whole. We did this on a delta math activity before, where if they canceled out, it was just a whole, but there aren't any cancelings going on in this case, so we'll assume that both of those are verticals. And again, you can check it on your graph if you're not entirely sure. So x equals 4 and negative 2. Asymptotes do need to be in equation form. Now going down to horizontal and slant asymptotes. What I want you to know about these is that these are mutually exclusive. Think of this as a group, because if I have one, I won't have the other. So it's going to be one or the other in this case. The case that we have is the equal degree. We've got squared over squared. So if you remember back to the beginning of this section, that means that we have a horizontal asymptote where we just take the coefficients and divide them. So we've got 1x squared over 1x squared. So that means we can make the horizontal 1 over 1, or just 1. What that means, though, is that we don't have a slant height. Slant height is reserved for that top-heavy case. This is an equal degree case. Now we'll take a look at the graph and maybe do a few things with domain and range. Well, domain, actually, we don't need to look at the graph really when we're talking about rational functions. We can just pretty much go right along with what we have for the vertical asymptotes. So that means if we're cutting it out at 4 and negative 2, you can put it on a number line, put them in order, negative 2, 4, those are wholes, and so now we use interval notation to describe those different chunks. So we've got negative infinity to negative 2, negative 2 to 4, all these rounded brackets, by the way, because they're wholes, they don't actually reach that point, and then 4 to infinity. Now, as I mentioned before, for the range, we need to consult the graph. And so first thing that I'd like you to do next, or that doesn't make sense, but what we're going to do next is we're going to graph this and then take a look at what it's telling us. So I'm just going to enter my function in an original form just from there. I like to do it that way because I don't have to worry about as many parentheses and gives me fewer options to make mistakes, which I always think is a good thing. So go to Zoom Standard just to see what we're dealing with here. I know it's a little hard to see on some of those, but we do get kind of a gist here. If we ignore the connections between those, we can take a look at what the range is going to be. Now, part of the range will have something to do with the horizontal asymptote. Notice that it's going along that horizontal asymptote here, and so everything above that is going to be part of our range. And so the one part of our range that I will say we can establish right away is everything from 1 to infinity. Everything up from there is going to work for the range. Now, below that, you'll notice that this other piece, this chunk in the middle, is a little bit different. It actually comes up above there. It doesn't go along the asymptote, and so here's what we're going to have to do. We're going to have to use the calc menu to help us out with this. I actually think we should maybe zoom in just a little bit to see what's going on here. It looks like it's topping out right about there. And so if we want to find out how high that actually goes, we're going to use the calc menu. So go second trace, find a maximum value. And here's our questions again, left boundary, right boundary, and a guess. I'm going to go way over here to make sure I've got my left. And then I'm going to go way to the other side just to make sure I've got enough space in between that I'm not going to one side or the other of the peak. And then I'm going to make a guess. And it looks like we have up to about 0.2597. I'm going to round that to 0.26 just for simplicity in this one. So if we're looking at that graph, if I've got that graph here from what I had on my calculator, the peak was at 0.32 approximately, and the y value was 0.26. Now we're looking for range, so we are only interested in the y value in this case, and that's going to be the bottom part of our range. So now I'm just going to put that in here and say that's negative infinity to 0.26. Now here's something a little bit strange. We're going to go up to that point. It is a rounded value, but I'm going to put a square bracket on that because we actually do get to this point. It's not an asymptote. We actually get there, and so I want to make that a square bracket. So that takes care of all the stuff except for limits, and so we're going to do the limits here now as our last piece of this. I have on this next page a graph written out, as you probably see on your completed notes. And we're going to do limits for not only end behavior, but also each vertical asymptote that's in this problem. So it's a good idea maybe to sketch in those asymptotes. We know them from the other page, but I've got my two verticals right here, and then I've got my horizontal right here. We're going to start one of the sets, we're all going to have pairs of limits, and so one of my pairs of limits is going to be for end behavior. I'm always going to have one set for just end behavior. Now that means as I go out to the left, as I go out to the right. So when we're talking end behavior, that's the one where we're going to put negative infinity for the x, and we're going to put positive infinity for the x. So that means to the left and to the right. Now the nice thing about rational functions is that usually when you go either direction, if there's a horizontal asymptote, it's going to be the same both ways. In this case, we knew that the horizontal asymptote was 1, so those are just equal to 1. The other thing is we're going to have a pair of limits for each of the vertical asymptotes that we have in this problem. So let's start with the first vertical asymptote, which is x equals -2. That was one of them we identified on the other page. And so what that means is that the x part that we're approaching is going to be for each one of these -2. Now, if you remember back to yesterday's video, we had to think about coming in from the left and the right. So there was this extra little notation where we did a 2 negative and a 2 positive. The little negative thing means coming from the left, the little positive means coming from the right. So now, as I'm following this thing in towards the vertical asymptote, and as I go from the left to this vertical asymptote, that's going to go up. And so I would put in a positive infinity for the limit on that one. From the other direction, it's going to be going down. From the right, it's going to negative infinity. Then I do another one. I've got another vertical asymptote, and so I have to have another pair of limits. So this one is going to be for x equals 4. I'm approaching 4 on both of them, but remember we have 1 that's coming from the left, 1 that's coming from the right. So now I think about, as I'm going towards this one, as I'm coming from the left, I'm reversing the arrows here, but as I'm coming in from the left, I'm going down. So I'm going to put negative infinity over here. As I'm coming in from the right, this thing is going up, and so I'll go to positive infinity. Most of the time you'll see those to be opposite with rational functions, but there's a pair for each vertical asymptote, and there's also a pair for end behavior. One last comment I'll make, I know this is a really long video, sorry about that, but one last comment I'll make is that in your assignment, numbers 37 through 44, those ones are the complete analysis problems, so follow this example for those and only include the items in that list. If you go with what the book has, it will be more items, it'll take you longer. So hopefully this, even though it was a super long video, hopefully this will help to refine what you're doing on each one of those problems.